So welcome to the exercise number 1.4 exemplar. Here the question goes like this. Show that first let us see the same questions, same type of questions we have two. Both are same. One is square, one is cube. Show that square of any positive integer is of the form 4q plus 1, and show that cube of any positive integer is of the form 4m plus 1, 4m plus 3 for some integer m. And let us see. So using 4 we were taking 4 different ways, 4q plus 1, 4q plus 2, 4q plus 3. Here for first question they asked us to square, second question they asked us to cube. Let's do that. First question, let us square. When you square 4q, 16q square. When you square this, a square plus b square, a plus b whole square, a square plus b square plus 2 4s are 8, 1s are 8 q. And which is, if you take 4q as common from these two, another 4q plus 4 2s are 8q plus 1. This one we suppose as, this entire one we suppose as 4 into m plus 1. Okay, and this one we can write as 4 into 4, you can take common, 4 into something, 4 into p. Similarly, if you square this one, 4q plus 2 whole square, 16q square plus 4 plus 4 2s are 8, 4q plus 2 whole square. You can do it. 16q square plus 4 plus 4 2s are 8, 2s are 16q. Now take 4 common. 4 into 4q square plus 1 plus 4q. Let us suppose this entire thing to be something like p. p हो गया ना, इधर m हो गया, p हो गया, then r. Similarly, if you do with this also, you will get 4 into something plus 1. So finally, what can we conclude? Either it is in the form 4 into something or 4 into something plus 1. So here that is what is asked, either 4 into q or 4 into q plus 1. These are the only two models possible. Similarly with the cube. For cube, instead of doing square, you will do the cube. Let's see once again the answer. So this is how you will answer the numbers. Possible numbers are 4q, 4q plus 1, 4q plus 2, 4q plus 3. This we have done in first exercise. Now cubing they are asking in second question. So let us cube all the numbers. Once you cube here 4 4s are 16 4s are 64 cube. Here a plus b whole cube, that is a cube plus 3a square b plus 3ab square plus b cube. Now here in all these things 4 is common, so you can take 4 common, and whatever is coming there, let us call it p, plus what is left out, 1. Similarly you can do this and this also. So here 64 4 into something we can write it, and there is no plus 1 plus 2 like that, so 4 into some p, let us suppose. Here we got 4 into p plus 1, here 4p we got. Now let us take these two and cube. 4q plus 2 whole cube and 4q plus 3 whole cube. This is again a plus b whole cube, a cube plus b cube plus 3a square b plus, just a moment, let us write for convenience purpose, a cube plus 3a square b plus 3ab square plus b cube, that is 2 cube. Now if you take 4 common in all these things, here something will come, something will come, something will come, that is here 4 square q cube, here 4q square 3 to 4 आ जाएगा, बाकी सब रह जाएगा वही, that is what I am saying. And here we get 4 चला गया तो 3 into q into 2 square plus इधर 2 cube, 4 चला गया तो so 2 cube 8 है ना, 8 को क्या लिखेंगे, 4 plus 4, या 8 को 4 चला गया था और क्या बचेगा 2. So this entire thing is 4 into something. So this is the form. So हमको क्या क्या चाहिए, 4m, 4m plus 1, 4m plus 3. हमें 4m आ गया, 4m plus 1 आ गया, 4m plus 3 वाला चाहिए था. सो और एक क्या चीज़ बच गया है, सी 4q का क्यूब कर दिया, 4q plus 1 का क्यूब कर दिया, 4q plus 2 का कर दिया. अभी 4q plus 3 का करेंगे, 4q plus 3 होल क्यूब. सो ये क्यूब प्लस 3 ए स्क्वायर बी प्लस 3 ए बी स्क्वायर प्लस b cube. Now here entire thing you can take common. 3 cube is 27. Entire thing let us take 4 as common. And here 3 cube 27 है ना, 27 में भी like 24 plus 7 3 I can write. So in this also I can take 4 common. So ये सभी से 4 common लेंगे up to here. और वो कुछ तो आएगा उसको हम m मान लेंगे. 4 into m plus क्या बच गया, 3. So the form is 4 into m plus 3. So what at all forms we got, 4m plus 3, 4m or 4p, कुछ भी लेटर हो सकता है, and 4m plus 1. So this is what is asked in the question. 4m, 4m plus 1, 4m plus 3. So this is how you solve the first two questions. Now let us see third and fourth questions. They both are same. Show that the square of n, here उधर can be बोला, इधर cannot be बोल रहे. Now let us see 5q is given na, 5q plus 1 or 5q plus 3 square they are asking. So let us take 5q means what are the possible options, 5q, 5q plus 1, 5q plus 2, 5q plus 3, 5q plus 4. Now they are asking us to square. Let us square. This one is 25q square. This one is a plus b whole square na, a square plus b plus 2ab, 2 5 is 10q plus b square. So here if you take 5 common, 5 into 5q square plus 2q plus 1. So let it be m, so 5m plus 1. Here if you take 5 common, 5q square, so इसको m मान लेते हैं, 5 into m. So what are the possible, 5m possible है, 5m plus 1 possible है. लेकिन इसको भी इनको भी इनको भी इनको भी करेंगे तो ये दोनों में ही आ सकता है, 5m plus 4 आ सकता है, 5m ही आएगा. लेकिन कहीं पे भी आपको 5m plus 5q plus 2 या 5q plus 3 स्क्वायर करने के बाद कॉमन करके ऐसा नहीं आएगा. So you can say clearly it is only possible to get only these methods. 5m we can get, 5m plus 1 we can get, 5m plus 4 we can get, but we cannot get 5q plus 2, 5m plus 3 model and 5m plus 2 model. So that is what you are going to write for both the questions. Try once. Next question, fifth one. Show that square of any odd integer. Odd integer means we have only one form. Odd integer generally is 2n plus 1 we take, where n is any natural number. So इसका square बोल रहे हैं. Let us do the square. A plus b whole square, a square plus 2ab 4n plus b square 1. So if you take this, what at all 4 if you take common, what will be left at 4n plus 2, sorry 4n plus n plus 1. Let us call this q. Then what happens, 4q plus 1. So square of any number will be of the form, for any odd integer is of the form 4q plus 1. Okay, now coming to the next question. Show that if n is an odd integer, n square minus 1 is divisible by 8. So this is the question. Let us see how to answer it. In the earlier sum we have taken odd number as 2n plus 1. Now here odd integer means we cannot take this, because 2n, if you 2n with 2, only 2 possibilities are there, 2n plus 1. This is even and this is odd. Now in this case we will take 4. 4 means we have so many options, 4n, 4n plus 1, 4n plus 2, 4n plus 3. Out of these two are even, so we don't take them. Now we want only odd, so let us take odd and find square. Show that n square minus 1 is divisible. N is an odd integer, na? So let us see this. squaring on both sides. 4n if you square, what happens? There are so many methods. I thought this is the easiest method. So 4n squaring. Let the even odd numbers be 4n plus 1, 4n plus 3. So 4n plus 1 whole square is equal to 16n square plus 2 into 8n plus 1. So you can take common 8 here, and we have, okay, this is a odd integer, and what they're asking is, let us just not confuse here. Let us in the question it is given n, so let us not take n here, let us take m here. So what happens? So this is the odd number, minus 1 we take, so n is equal to 4n plus 4m plus 1. So n square minus 1 we need, so in place of n square minus 1 we have 4m plus 1 whole square minus 1. So this is the 4m square, 16n square plus 8n plus 1 minus 1. So 1 get cancelled. So you take 8 common. 8 into 2n square plus 2n. So it is divisible by 8. Similarly, if you take 4m plus 3 also. So this is the odd number, let us suppose. Now what happens? N square minus 1 we need. That is 4m plus 3 whole square minus 1. 16m square, 2 4s are 8, 3s are 24m plus 3 square, 9 minus 1. So 16m square, 24m plus 8. If you take 8 as common, 2m square plus 3m plus 1. So divisible by 8. Next question, show that x and y are both odd integers, then x square minus y plus y square is even but not divisible by 4. It's very easy, you can do it simply way in any of the way. In the previous question you have taken x as odd numbers. What are the possibilities? 4n plus 1 and another odd number 4n plus 3. Now x square plus y square, there you have already done a plus b whole square, and this is 16n square plus 8n plus 1. This is 16n square plus 2 4s are 8 is 24n plus 3 square, that is 9. Since let us add these two, what happens? 16 2s are 32n square, 24 plus 8, that is 32n plus 9 plus 1, 10. Is this divisible by 4? No, this is not divisible by 4, because if you divide it with 4, 4 8s are 32, 4 8s are 32, and out of this 10, 4 2s are 8 आ जाएगा, और क्या बच जाएगा? Remainder 2. So it is not divisible by 4, it leaves the remainder 2. That's what we write. And coming to the next question, using Euclid's division lemma, this you have done, but here there are 3 numbers. First you do for 441 and 567. Whatever answer you get, with that answer you do 693. So 2 parts you are doing this. Here again next question, let us see the next question separately. Using Euclid's division algorithm, find the largest number that divides 1 2 5 1 9 1 2 5 1 9 3 7 7 1 5 6 2 8. मीन्स लार्जेस्ट बोला है, हमेशा याद रखिए लार्जेस्ट, मैक्सिमम, हाइएस्ट इज नथिंग बट HCF. देर आस्किंग अस टू फाइंड आउट HCF, बट देर इज़ अ रिमाइंडर कॉन्सेप्ट आल्सो. इसके साथ रिमाइंडर 1 आना चाहिए, इसके साथ 2 आना चाहिए, इसके साथ 3 आना चाहिए. जस्ट सब्ट्रैक्ट दोज नंबर्स, वॉट एवर इज द रिमाइंडर. नाउ वी गेट द नंबर्स 1 2 5 0 9 3 7 5 1 5 6 2 5. Taking prime factorization method, find the HCF of these 3 numbers. Now root 3 plus root 5 is equal to irrational दिखाने के लिए बोला. Let us suppose opposite मानते हैं ना, let it be rational and let it be a, not a by b. Now root 5 is equal to a minus root 3. Squaring on both sides, root 5 square is 5. ये पूरा स्क्वायर करने से a square plus 3 minus 2 root 3, sorry 2a root 3. So on RHS it is irrational number, and LHS it is a rational number, which is a contradiction arised because of our wrong assumption. So root 3 plus root 5 is not rational, it is irrational. That is how you will write. And coming to the next question, 12 power n 12 का प्राइम फैक्टरेशन क्या है, 2 6 ज़र, अगेन 2 3 ज़र, सो 2 स्क्वायर इंटू 3 होल पावर n। किसी की प्राइम फैक्टरेशन में अगर एंड विथ 0 और 5 होना चाहिए तो उसमें 5 होना चाहिए, लेकिन हियर देर इज़ नो 5, सो 12 पावर n कैनॉट एंड विथ 0 और 5. And coming to the next question on morning walk, 3 steps. These questions always are LCM. Just find out the LCM of all the 3 numbers. Now here write the denominator. Let us see the next last 2 questions in the next page. Write the denominator in the of 2257 by 5000 in the form 2 power m 5 power, and let us write 5005 into 1000, again 5 into let us do this way, 5000, no, okay, that's right thing, 5 into 1000 and 5 into 1000 को और क्या लिख सकते हैं, 5 2s are 100, 200, next 5 into 5 into 5 into 5 4s are 0, again 5 cube into 5 into 5 8s are 40. Now 5 power 4 into 2 power cube. So the rational number 257 by 5000 becomes 257 by 5 power 4 into 2 cube. Sorry, 2 cube. Now what they're asking is, they're asking us to find out its decimal expansion without actual division. Simple, इधर जो पावर है उतना ही पावर इसका इसमें भी होना चाहिए. सो लेकिन इधर 2 पावर 3 ही है और एक 2 चाहिए, तो 2 से मल्टीप्लाई करके 2 से डिवाइड करेंगे. तो 257 इंटू 2, 2 7s are 14, 2 5s are 10, 5, sorry, 2 7s are 14, 2 5s are 10 plus 1, 11, 1, 2 2s are 4 plus 1, 5, 14 by here 5 power 4 into 2 power 4, that is 5 14 by 5 2s are 10, लेकिन ऐसे कितने 5 2s are है, 4 है, तो 4 zeros आएगा. So this becomes 0.0514. This is how we do. एंड वैसे आंसर कितने डेसिमल के बाद टर्मिनेट होगा, तो मैक्सिमम वाला बता देते थे पहले ही 4. दिस वी हैव डन इन द मेन एक्सरसाइज आल्सो. Now we are left out with only one question. Root p plus root q is irrational. No, very simple. सेम वे हमने जैसे इससे पहले भी किया था, √5 plus √3 वाला सेम मॉडल है. रूट p plus root q is equal to ये. Let us suppose it is rational. Let us assume √p plus √q is rational and is equal to a. Now q को इधर भेज दीजिए. √p is equal to a minus √q. Now squaring on both sides, what happens? This becomes p. This is a minus b whole square. It becomes, so that is a square plus b square minus 2ab. On right hand side it is irrational number, left hand side it is a rational number. Contradiction because we have assumed wrong, so √p plus √q is irrational. So this is how you will solve the exercise, exemplar exercise number 3, and you have 1 day time. Complete the notebook and submit by tomorrow.